So next video, I want to cover how you can rewrite the vertex form into the standard form. So basically, I need to expand this term here. So this is a bracket square. I need to solve for this one. So remember from what you learned in Math 10 classes, you have dealing with how you can expand the square root expression a minus b squared, and a minus b squared equals to a squared minus 2 times a times b plus b squared. So basically, if I have this term here, I can rewrite this one as x minus 1. So x equals to a, b equals to 1. So I'm replacing a with x and b with 1. So I got x squared minus 2x times 1 plus 1 squared. So which gives us x squared minus 2x plus 1. So x minus 1 squared, I can rewrite this expression as x squared minus 2x plus 1. And I'm going to add 2 in this equation. And I get the y equals x squared minus 2x plus 3. And this is my standard form of this equation. So next I want to cover what is the y-intercept, axis of symmetry, domain, and the range for this equation, for this function. So we have y equals x squared minus 2x plus 3. I want to determine the intercept and the y-intercept. So basically y-intercept is saying that what is the y value when the x here equals to 0. So I'm making the x equals 0 and I want to figure out the y value. So how should I do that? So basically I need to replace the x here with 0 and I'm doing y equals 0 squared minus squared plus 3. So when I do this calculation, I got y equals 3. So which tells us that the function will cross at the point 0, 3. And also the constant here, the last term, tell me that this is my y-intercept. It's crossing this point, 0, 3. So next, I want to know what's the axis of symmetry for this function. So basically, the axis of symmetry is a vertical line which crosses the vertex of this function. So basically, I need to know what is the x-coordinate of the vertex is always equals to the axis of symmetry. So the axis of symmetry, the equation is x equals to the x-coordinate of the vertex. So in this case, which is 1. So x equals to 1 is the axis of symmetry for this function. So next I want to figure out the domain and the range. So the domain is all the real numbers. So every quadratic function has the all real numbers domain. So it doesn't change for every quadratic function. So how could I figure out the range for this function? So basically this is what I know so far. So I know that a value should be greater than 0 and it's a positive number. So basically when a value is greater than 0, the vertex must be in the minimum position. And the 2 here is the minimum y values because the parabola is going open up. So everything must be greater than 2. So we have y greater or equals to 2 from our range. So basically this is the electronic version of y equals x squared minus 2x plus 3. So we could see that the vertex is at 1, 2 and it passes through 0, 3 and the y-intercept equals 3. So basically if I want to look for y-intercept, I need to look for the last term of the function 3 and give me 0, 3.